everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky. This week, we're talking about the week of May 23rd, 2022. So, last week, what we talked about was the region around the North Celestial Pole with the Big Dipper, the Little Dipper, Draco, and so on. So we looked at what we could see at the North Celestial Pole. That was a fun little look at what was in the night sky. This week, we're going to, so I'll tell you, we'll give you a little insight into how I was thinking about this, how my mind worked in this direction. So the North Celestial Pole is the projection of the Earth's North Pole onto the sky. We take the lines of latitude, and the lines of latitude get projected onto the sky, and those lines of latitude are then called declination on the sky. So each star has a declination and a right ascension. The projection of longitude on the sky is right ascension. And so we have a right ascension and a declination. That's the celestial coordinate. So we can define the position of any object in the sky with its declination and its right ascension. So we can think about looking at the inside of a sphere, and we see these lines on a globe projected onto the inside of the globe that is the celestial sphere around us. So the North Celestial Pole has a declination of plus 90, and we explored that region just a little bit last week. We're going to take that in a slightly different direction this week. One of the things I like to think about, one of the things that I like to do is to say, okay, now, whatever your latitude is, wherever you are right now, whatever your latitude is, when you project it onto the sky, objects of that declination will pass directly overhead. We call the point directly overhead the zenith. So when you look straight up, you're looking at the zenith, and objects that are at the zenith will have your declination. For me, that's about 43.3 degrees north latitude. So objects about 43 degrees can pass at the near the zenith. And so they can at some point, they rise in the east and they set in the west, and they move across the sky as we rotate. And so they're not at the zenith, they're only at the zenith for an instant, for a moment, as they're moving across. But they can be there at the zenith. We like to look at the things around the zenith. We're looking through less atmosphere when we look directly overhead, right? If you're here on top of the world, looking down on creation, right? The Earth's atmosphere, not the scale, the Earth's atmosphere is around here. You've got a shorter path to look that direction than you do that way. So there's a lot more atmosphere, thicker atmosphere, you're looking through that direction. So when things are closer to the horizon, you'll see stars twinkle more, and you'll have more scattering of light, more reddening, more sort of blurriness. And so things are better observed when they're closer to the zenith, near straight up. You get a little bit better imaging, a little bit better quality of your observation. So we like to look at that. So one of the things, what we're going to do this week is, because I don't know where you are, I do know where I am, kinda. Most people would say I don't ever have any idea where I am or what I'm doing, but that doesn't matter, does it? I'm at 43 degrees north latitude, so I'm going to go through the exercise of saying during this week, what objects will be near the zenith at different times during the night. And there could be a lot of them, but we don't have time to look at a lot of them. We're just going to look at three of them, sort of three constellations here this week, to say these are objects that have, these are constellations that contain objects that have a declination around 43 degrees. And this is an exercise you can do for yourself. If you're located a good distance away from me, if you're not, if you're within 5 degrees of me or 10 degrees in latitude, then these objects will get pretty close to the zenith for you this next week as well. And they rise 4 minutes earlier each night, so they'll be near the zenith at some time during the night for the foreseeable future. So we're going to start with the Big Dipper. It was way up north, right? It's very close to the North Celestial Pole. But we can find from there, from the Big Dipper, if we go south from the handle of the Big Dipper, we come to the relatively bright star, third magnitude. That's not that bright, but it rivals the Dipper handle stars right there. So to say, let's make something that looks like that, maybe over to the bowl, or even this pattern up this direction, maybe up to the handle star. Let's do that way. And that makes a sort of kite shape, which actually mimics Boötis that we're going to talk about here in a moment. And so about the length of the handle down, you come to a well-known star, Cor Caroli. So Cor Caroli is the third magnitude star. It's the brightest star in that region, so you can pick it out. You don't have to go fishing for it. And so this is the alpha star of Canes Venatici. So now you got a new constellation. If you haven't seen Canes Venatici before, you just found the brightest star in there, and the fainter stars around this region are part of Canes Venatici. And to this whole region we talked about last week, go watch it now. We'll wait for you. Go watch last week's video to talk about this region of the sky. This region of the sky is full of external galaxies. We talked about why that was, geometries and so on. And we still see external galaxies here in Canes. We've got M63 and M94 in particular right here to say, if you take the N star in the handle of the Big Dipper and draw a line to Cor Caroli, right on that line is M63, the spiral galaxy. If you look back at the handle the other direction, you'll go right past M94, a spiral galaxy. M63 in particular is the object that's going to get closest to the zenith for me. Okay, so this region of the sky is going to be on the zenith for me about 10 p.m. as we've got good and settled dark. So we've got good and settled dark, and I go outside and I want to find some stars. I'm going to look up. I'm going to see the Big Dipper. I'm going to find the handle of the Big Dipper. I'm going to use it to find Cor Caroli, and then we're going to identify Canes Venatici that way. And I'm going to use it then to try to poke around and find M63 and M94. And M63 is going to be on the meridian for me about 10 o'clock this week. So it's going to be on the zenith. The meridian, I'm sorry, we didn't define that. The meridian is the line that connects north to south directly overhead, passes through the zenith. So all objects that you can see in your sky at any time will at some point in time be on the meridian. Only objects that have a declination equal to your latitude will be on the zenith. It's all making sense and it's all fun, right? Geometry is fun. So we're just having loads of fun. We're finding a couple of more good galaxies here, little faint smudges of light. But my goodness, it's fun to see these little faint smudges of light and think about the hundreds of billions of stars that make up those faint smudges of light. So that's where I'm going to start the evening. A couple hours later, near midnight. Sometimes midnight has a T on it. I see I wrote it earlier without the T. Midnight, we're going to call it from now on. Okay, we're going to practice that. So sometime around midnight, the constellation Boötis is going to come up and get on the meridian for me. Now this is a weird one because Boötis is so long, it's so big and stretched north to south that Arcturus, the brightest star in Boötis, which we find, remember, by arcing from the handle of the Big Dipper. We follow the arc down to Arcturus. This isn't to scale with that, but it is that curve. You can follow down to Arcturus. Arcturus is only about 20 degrees declination, so it never gets within 20 degrees of the zenith for me, with a couple of fist widths down. So it's not way off the zenith, but it's not terribly close to the zenith. But this stretches so far up this direction that we do get near the zenith. And for me, the star that gets closest to the zenith that I'm interested in right here, I think it's got, if I remember its declination, I should have paid attention to this and looked it up. I think it's about 45 degrees. So I think it gets within a couple of degrees of the zenith for me, is 44. Okay, 44 Boötis is this star right here. And the way I find it is Boötis looks like this kite shape to me. There's a spectacular photograph, an image of this on our webpage. Go to luther.edu/astronomy and then look at asterisms. And so with my cell phone, I go out and I take pictures of patterns of stars, asterisms like this. And Boötis is out there, and several of these stars are marked, including Neckar, the star that's at the top of this upside-down necktie, like this. There you go. Ooh, upside-down necktie. Or the kite shape like this, and just above Neckar. So if I make a right triangle right here and right up here, I come to 44. Now 44 is about a 5th magnitude star. You can see it, but it's hard to see. Okay, you're getting down into faint stars. I think it's 4.8 or 4.9 magnitude, and you can see this Here, Neckar itself is 3.5 magnitude. And this 44 is right at my zenith right now at around midnight. And what's beautiful about so there's a string of fifth. So Boötis has a couple of brighter stars, not super bright stars, but a little bit brighter than this, stretched out this direction. And there's a whole strand of fifth and sixth magnitude stars trailing off this way. But if we sort of make a right triangle with these two stars in the kite, in the tie of Boötis, and up to here you get to 44. 44 is a binary star, a beautiful, fun binary star, pretty easy to separate in your small telescopes. You've got your telescope out poking around, trying to find M63 and M94. Then you're going to go look for 44, and you're going to see this wonderful double star. And one of the great things about 44 is that we've seen it orbit. We've had enough time. We've observed this binary star for long enough that we've seen the orbit, and it's a very elongated orbit. A lot of these orbits are pretty circular, but this is not a circular orbit. This is a highly elliptical orbit, and so we see this very, very elliptical orbit of this binary star. Fun to watch, fun to think about, and fun to look at. So we've got Canes Venatici, Corcaroli, new star for us, maybe new constellation, a couple of fine galaxies to look for there. Then we hop across to Arcturus and Boötis, which we've looked at before, but I don't think we've ever tried to find 44, this binary star. Now, we wait a couple of hours later until we get about 2 a.m., and I don't think I wrote that on the board. So for about 2 a.m. for me, Hercules is going to be on there, and I don't think we've ever talked about Hercules. I think we did one time talk about Hercules. Hercules is sandwiched between Arcturus and Vega. The bright star Vega in the summer triangle is up here. So if you go from Boötis up toward Vega, you're going to pass right through Hercules. And I know we talked about this before, because I know that I remember saying that there are certain patterns of stars in the sky that for whatever reason, and I don't know why, for whatever reason, I have a hard time finding sometimes. And then all of a sudden, boom, I lock right in, and there they are. And Hercules is one of these. The keystone of Hercules is this shape of the body right here, and there's some legs and some arms up this direction. But we try to find this pattern right here. And it's squarely between Boötis and Vega, the bright star Vega in Lyra up this direction. And about 2 o'clock in the morning, this is going to slide past the zenith for me. And in fact, what's nearest the zenith, there are two beautiful globular star clusters here. One of I think the most famous globular star cluster of all is M13 right here, about a third of the way down the right side, the west side of the keystone of Hercules. About a third of the way from the top star to the bottom star, you run across big, beautiful, bright M13. Go out and look at pictures of it. We have one on our website too, if you just like going to our website to look at stuff. But there are better pictures of this out there. I'm out on a limb and say there aren't that many better pictures of Boötis out there than what we have. But this is a fine picture we have out there, but there are people who've taken pictures of this with huge telescopes on mountaintops and with different colors, filters and stuff. And so you can find a world of M13 photographs out there, and it's a big, sprawling, beautiful globular cluster. But M92 is up here. So if you look above the top of the keystone and move up this direction about that distance, maybe a little less than that distance, up and over just a little bit, above the keystone up here is another globular cluster, M92, very fine globular cluster in and of itself. That's what's going to pass closest to the zenith for me, given its declination. So at 2 o'clock in the morning, I'm going to be out looking for M92. I'm not going to not look for M13 at the same time. I'm going to identify the star pattern, the keystone of Hercules, as I move from Boötis up to Vega. Vega itself is a very bright star. It's one of the brightest stars that pass very near the zenith for me. And it'll be there about 3:30 in the morning, about an hour and a half after Hercules gets there. But we don't have time. We've already talked enough. We're not going to go on that direction. This is enough. This is beautiful stuff. I hope you have clear skies. I hope you have a chance to get out and keep looking up and look at the zenith wherever you are and identify fun stuff sliding past it. As always, thanks for watching, and we'll have something more for you next week.